We have another loop problem that we have right here, okay? And so we have a left loop and we have a right loop, all right? So if we look at the left loop, we'll do this one clockwise. So we can start at A, we come down, and so since we're going against the resistor, we're going to have a minus I2 times 10 ohms times 10 ohms. We're going to go from a positive to a negative, so there's going to be a decrease in potential. It becomes minus 2 volts. Come over to here. We have an increase because we're going from minus to positive, so this becomes plus 10 volts. And now we're going to once again go with the current to 5 ohms, so this becomes minus I1 times 5 ohms, and this is equal to 0. Now we can rewrite this without the units, all right, so this becomes a minus I2. Let's just rewrite that all over. Let's just start this all over here. So this becomes a minus 10I2. This becomes plus 8 volts. Or we'll just get rid of that. It becomes a plus 8. All right. And this becomes minus 5I1 is equal to 0. We can rewrite this now as a minus 10I2 minus 5I1 is equal to a minus 8. Is equal to a minus 8. Let me make sure, check my notes, make sure I've not made any mistakes. Nope, that should be good. Now, if we look at the right loop, let's look at the right loop over here. So we have the right loop. All right. For that one, what we're going to do is we're going to go counterclockwise. So we can go counterclockwise on it. Once again, starting at A, so we're going to go this way. We once again have a minus I2 times 10 ohms. We're going to have a drop of 2 volts. Come over here to I3. We're going to have an increase, since we're going from minus to positive, of plus 15 volts. And then since we're going with the current, this becomes minus I3 10 ohms. And this is equal to 0. Once again, we can rewrite this and get rid of some of the units. So this becomes a minus 10I2 minus this becomes 13 minus 10I3 is equal to 0. Now what we can do is we can put the 13 over to there. This becomes a minus 10I2 minus 10I3 is equal to now 13. All right. So we have these two equations right there, but we still need another equation. And for that, we can use the junction rule, and A is going to be our junction. So if we notice, both I1 and I3 go into A, and then I2 goes out. And so for our junction rule, which would be the third equation we need, because right now we have just these two equations with 1, 2, 3 variables. And so what we have now is we have I1 and I3 going into the junction, and what's going out now is I2. All right. Now what I've done is I just simply rewrote the three equations we're going to be using. If we look at this equation right here, we can solve this now for I1, and this is going to be equal to I2 minus I3. We can substitute it into there, and we end up getting minus 10I2 minus 5I2 minus 5I3 is equal to a negative 8. Or we could say this is a minus 10I2 minus 15. Oops. I keep making that mistake. Minus 15I2 minus 5I3 is equal to a negative 8. Is equal to a negative 8. Oh, this becomes positive. That becomes, there we go, there's a mistake. All right, it becomes positive, positive, positive. sorry. All right, now what we've got here now, so let me get rid of that. I dropped a negative there, so that should be positive. All right. Now we can bring that one down. So we have a minus 10i2 minus 10i3 is equal to a negative 13. It's equal to a negative 13. Now let's see, what can we do here? All right, well, I'm going to make this positive. I'm going to make this negative. I'm going to make that positive. Likewise, I'm going to make this positive. I'm going to make that positive. I'm going to make this positive. You'll see why I'm going to do this real soon. Because if I hadn't done it that way, I would have gotten a negative current. We can't really have a negative current. If I multiply this by 2, all right, and I add this up, 2 times 15 is 30, plus 10 is going to give me 40 I2. 2 times a negative 5 is going to give me negative 10. That will cancel with this. If I do 2 times 6, or sorry, 2 times 8, this is 16 plus 13 is equal to 29. So my I2 is equal to 29 divided by 40, which is going to be equal to, let me check my cheat sheet, this is going to be 0.725 amperes. So my I2 is equal to 0.725 amperes is what that's going to be equal to. Okay, if we look at this equation right here, so let's work on this one right here. We have a minus 10. Now we already know what I2 is, so we can substitute that in. 0.725 minus 5I1 is equal to minus 8. All right. And we can make this positive, make that positive, make that positive. And so this becomes 7.25 plus 5I1 is equal to 8, or 5I1 is equal to 0.75, or I1 is equal to 0.15 amperes. So we know that I1 is equal to 0.15 amperes. We can use this equation right here and solve for I3. So now I3 is equal to, a negative I3 is going to be equal to I1 minus I2, or I3 is equal to I2 minus I1. And so therefore this is going to be equal to 0.725 minus 0.15, and that's going to be equal to 0.575 amperes. Just remember, the current can't be negative. We can't have a negative current, all right?